Right. Yeah, let me share my screen. Yeah, so hi everyone, welcome to Multimodal Weekly. This is a virtual webinar series hosted by the team at TwelveLabs. A little bit of context for those of you who are new, we are startup in the AI space focusing on building video understanding models. Multimodal Weekly is a community initiative that we've been doing over the past 2 years or so, 2.5 years, in which we meet on a weekly basis and, as the name suggests, discuss some of the most exciting, topics on the broader domain of multimodal AI and foundation models. Sometimes we have researchers coming and talk about their papers. Oftentimes we have builders, operators, developers talk about different applications that they build in different verticals with multimodal understanding. And then obviously we have partners, users, and internal team members coming and talk about how to use our technology, platform, and APIs. These are some of the sample session of some of the recent session that we had. We got, a lot of folks building with our technology, come and share, different projects they're working on. We have partners coming and talk about how to use, tools for customer use cases. We have researchers coming and talk about multimodal LLMs, for example. For today's session, I'm super excited to have three wide-ranging presentation that will cover our 45 minutes of content. The first talk will come from Soyeong, Kangsan Kim, and Jin Hyun Baek. They both dialing in from, I assume you guys based in Seoul, but maybe not. But they come from KAIST, and they will present their paper called VideoRAG, which is a very interesting framework that dynamically retrieves video based on their relevance with queries and also utilize visual and textual information. RAG over video is obviously a very exciting topic that our team at TwelveLabs has also been digging into. So we'd love to learn more about some of the academic initiatives and how the KAIST team has been working on and to make it happen. So that will be the first presentation. And then the second and third presentation were actually coming from some of the student developers who've been working with our technology in a recent hackathon that we did in Toronto, Canada. The second group, including Neha, Daevik, and Kaniesa, will present their work called Solari, which is an AI-powered wearable for the visually impaired. Using ultrasonic distance sensors, Barsa, and a camera, this project detects nearby obstacle and identifies some of the key objects to have, some of the folks with visual impairment navigate safely and confidently. And then the last talk will come from Karan, Aditya, and Barsa. They will talk about their project called Coach.ai, which is a spot analysis platform that democratize professional coaching through personalized video feedback for underrepresented athletes. So yeah, that's the high-level details about the talk that we have today. Just quick logistical note for other attendees before you send your question on the Zoom chat, and then I think the speaker can answer them asynchronously if they see it. If time allows, we'll have a short interactive Q&A session after his presentation finish. So with that, I'll stop sharing my screen, and then I've let the first group present the slide.
Okay, thank you for your introduction, and I will share my screen. Okay. So, can everybody see my screen?
Yep, let me see it.
Okay, so let's get started. Hi everyone. My name is Soyeong, and first of all, we're very thank you for giving us the opportunity to present our work, VideoRAG, retrieval augmented generation over video corpus, which we presented this work in ACL this year, and we are Soyeong, Kangsan, Jinon, and Professor Sungju Hwang. And in today's webinar, we're gonna present not only our work, VideoRAG, but also some possible future work direction to extend our work. So yeah, so let me introduce ourselves really briefly. So today, me and Kangsan will gonna give a presentation, and I'm gonna like give the like high level overview of motivation and some approaches used in VideoRAG, and Kangsan will give some like experimental results and some very interesting future work direction to extend our work. And my name is Soyeong, and I'm currently a fourth year PhD student at KAIST, and I did my internship at Amazon for twice, and my research interest is mainly on LLM and RAG. And Kangsan is a second year PhD student at KAIST, and he's currently in NYU as a visiting student, and his research interest is mainly on multimodal LLMs and agents. So let's get started. I think many of you here are very familiar with that recent LLMs such as ChatGPT or Gemini are very effective, but also they're very prone to the limitations called hallucination. And this is the like exact example of the hallucinated results from the ChatGPT, because I prompted the ChatGPT to tell me about Kangsan Kim at KAIST. And while it gave some accurate information like his affiliation or advisor, but it also gave some very inaccurate and hallucinated responses like his education because he completed his BS in 2024, and also like giving some like random results on like inaccurate image profile picture. And in order to solve this hallucination problem, the most like widely used technique is called retrieval augmented generation, in short RAG, which leverages external knowledge to improve answer quality by addressing the limitations of LLMs whose internal parameters are not perfect. So for example, given the query like how many of the elements are radioactive, then the retrieval module searches for the query relevant documents from a very large like corpus such as Wikipedia. And then with this retrieved document, the generation model generates the answer grounded on this external and retrieved document and gives some like accurate prediction. However, we found out that existing RAG system focus mainly on text and image domain, but they're missing out on very rich potential of videos which contain like temporal dynamics and spatial details. So for example, for like given the query like after crossing the white end, what's next in tying a tie? And we thought that for this query, it would be very beneficial to use the video content because it contains very dynamic sequences of how to like tie a tie in a very like step-by-step order. And in contrast to the like textual RAG or conventional image text RAG, which only focuses on like retrieving the static information, we thought that like video can contain like more reach and more like more helpful information within the video. And to be more specific, within a video modality, we use both of the visual features and the texture features. Like texture features here, we mean that like there are like transcriptions of the video, and by using both of this visual and textual features, when incorporating both of the features, we can correctly answer to the query of like after crossing the white and what's the next tying a tie. So in short, this is the overview of our video RAG pipeline, and it is quite like similar to the conventional RAG pipeline. So given a query, we first retrieve the video from a large video corpus, and then with the like retrieved video, the generation model generates the answer by grounding on the retrieved video. However, we found out that there are very unique challenges in operationalizing video RAG, and this is because videos are inherently long and redundant, and making it inefficient and sometimes infeasible to process all the frames specifically for the long videos. So for example, in a like retrieval stage, there can be very many videos, and in a generation stage, one like some videos can be very, very long, and it would be very infeasible to process all the frames within that video. So we further propose to train a frame selection network consist of MLP layers. And by doing so, we can select the most representative and relevant keyframes within videos in both of the retrieval and generation stage. So for example, in a retrieval stage, our objective is to find which frames best represent the video. And in a generation stage, our objective is to find which frames help answer to the specific query. And according to these two different like objectives, we aim to find the optimal set of the frames that can have very high similarity for the like retrieval stage and high generation score for the generation stage. And by doing so, like by training the like frame selection on such like objectives, then during the inference stage, we can effectively and efficiently utilize our VideoRAG framework with only like by using the this frame selection strategy. And actually, I'm giving very like high level overview of our frame selection model. And if you're more interested in how to train our like specifically train this network, please I truly recommend reading our paper. And from now on, Kangsan will give like his half of the presentation, starting from like experimental set of our like VideoRAG framework.
All right, thank you, Soyeong. And yeah, let me continue from the experiment setting and the result here. So, oh yeah, I can share my screen. Can you see it?
Yes.
Yeah, cool. So yeah, so this is the experiment setting, and yeah, for the benchmark, we use WikiHow QA, which is focusing on the how-to questions, and we also generate some general QAs and using GPT and name it synthetic QA. And as a video source, we use how-to 100 million video set as a like video corpus. And as a baseline, we use naive, which doesn't use any RAG, and also text RAG, text plus image RAG, and also the text video RAG, which is only using text information of the video in retrieval and generation. And we have two variants of VideoRAG. VideoRAG V means that using video in the response generation, and VideoRAG VT means that using video and also the text information, which is scripts in the response generations. So as a backbone model, we use Lava Video, InterVL 2.5, and Qwen 2.5 VL. Yeah, and this is the main table of our video log evaluation. So as you can see, based on compared to the other baselines, our video log models achieve the best result in WikiHow QA and also the synthetic QA. And this tendency is also across the all different three different kind of base backbone models, as you can see in the table. And we did some analysis. So if you see the table two on the left side, when we do the retrieval, not only using just for visual or text information only, but using both of the information from visual and texture information achieves the best performance in the video retrieval. And if you see the figure 3 on the center, then it means that in the embedding space, if you plot the script features, which is the texture feature of the video and the visual feature of the video, then there's a huge modality gaps between the text and visual information. So it demonstrates that two different kind of modalities provide two different kinds of knowledge. So we should exploit both of them in retrieval and also in the generation stage. And for the adaptive frame selection method, if you see the table 3 on the left side, then in retrieval and generations, both of stage, our adaptive frame selection method outperforms the uniform sampling method. And also, if you see the right side case studies, then if the video is about the cleaning artificial flowers, then the frame selected by the uniform sampling actually doesn't have any flowers image. But if you see the right side selected by our adaptive selections method, then there's some like cleaning scene also there's some image of flowers are selected. And also for the generation part, if you see if the query is about explain how to cut acorn squash, then if you use the uniform sampling method, there's really redundant frames are selected. But by using our adaptive frame selection method, there are less redundant frames in, as you can see in the right side. Yeah, and this is the case study of response generations. So yeah, if the user asks about explain how to bake cookies on your car dashboard, then without any information, additional information, the model has no idea about how to bake a cookies on the car dashboard. So it says that I'm sorry, but it's not possible to do it. But actually, there's a video about baking cookie in the car dashboard like this. And by using this information, our VideoRAG framework can correctly answer the questions about how to bake a cookies on the car dashboard. And so in terms of the future research, I mean, following research, we are focusing on the how to do RAG adaptively. So this is one previous work that named adaptive RAG, which addressed the diverse query complexities. So if you think about the real world queries, it could be a simple questions or it could be a complex questions. So it varies a lot. So adaptive RAG here learns to allocate retrieval of effort where needed. So if the simple code comes in, then we just do the single turn retrieval, augmented generations. And if the complex queries comes in, then we can do the multi-hop, multi-step retrieval augmented generations. So by doing that, we can save cost on easy question and also boost accuracy on the hard questions. So inspired by this adaptive RAG, we want to apply this into the multimodal retrieval augmented generations. But actually, no single modality fits all queries. So query diversity is not only about the complexity, but it also about what kind of knowledge maybe for each, it should be benefited by the text information or image information or video information. So for example, like if the user query is about where was the CEO of Meta born, then rather than using the image of CEO of Meta, we can use some texture information from maybe Wikipedia information of the CEO of Meta. And also, if the user asks about how did Messi score the last game, then definitely just watching the video of the last game is much more helpful rather than just reading a text of the last game. So in that case, we want to use this multimodal retrieval augmented generation more adaptively. So we suggest the new framework that named UniversalRAG, which is query adaptive and modality-aware retrieval framework. So in UniversalRAG, it prepares multi-level corpora and use a router to dynamically choose both modality and granularity. So basically, because there's a big modality gap between the text, image, and video, we just separate each corpus and let the router choose which corpus should be adapted for each query from the users. So those are our takeaways from this talk. So first one is about current RAG system mainly focused on the text, but real-world queries also demand video modalities with its unique characteristics. And also, video is long and redundant, so choosing the right frames improves both efficiency and accuracy. And lastly, not all queries requires the same types of scale, the same type or scales of informations. So beyond video, we should adopt retrieval across modalities and granularities. Yeah, so this is the end of question. It is end of our presentation, and thank you for listening.
Awesome. Yeah, thanks, Kaniesa. Yeah, you can just keep this slide here so folks can take a look at the link. I think there's a couple of questions on the Zoom chat if you guys can answer them. for the next 5 minutes.
Mm-hmm.
I think the most recent question was about like the UniversalRAG framework and how, do you just want to read it and answer it?
So yeah, since we argued about Kevin's questions, and let's move on to the Devansh questions. How the router choose which modality to direct the queries? So we trained the router using the different kind of data set. So actually we gathered different kind of RAG benchmark data sets. So for example, it's like we train the router that maybe, for example, there's a text RAG a benchmark data set, then we train those kind of queries as we should leverage text information. The router should route to the text corpus for those kind of questions. And for the video RAG queries, we brought some queries from the video RAG, like how to questions, and train those queries to the router that the router should route to the video corpus when it comes to those kind of video RAG queries. Yeah, so basically we just leverage different kind of benchmark exists in the different kinds of multimodal retrieval benchmarks. And yeah, for the Kevin's follow-up questions, what metrics would you measure in visual similarity? Is it just this cosine similarity or after vectorized? Did you make use of any modern means such as 12-step summarizing API? Yeah, I'm actually we didn't use any 12-labs API. We just do the cosine similarity based on the video encoders features. Yeah, but if you use more like better ways such as like TwelveLabs API, then I guess the retrieval performance could be better. And how would you extract audio information from a video, or is VideoRAG simply fetching from visuals and texture captions? Yeah, actually, we use if there's a script are given along with the video, then we just use that script. I mean, written script. And if there's no transcripts are given, then we use ASR models. So just get the text information from those audios. And for next question, what types of data are you able to derive from video that contains music or musical performance other than dialogue? Yeah. So maybe if the user asks about asking about some like certain musics or like a musical performance, then we can leverage that kind of audio information as well in retrieval stage. So yeah. So not just rather than just using visual and texture information, we can adopt more audio specific encoder and use it in the ensemble stage. And I think by those kind of ensemble between visual, texture, and audio information, then yeah, you can provide or retrieve like relevant music or musical performance based on the given queries from the users.
Perfect.
Yeah.
I know that we have a bunch more questions in the chat. So if you like, maybe Soyeong, Kangsan, and Jinhon, you guys can answer it asynchronously via Zoom for the remaining question, right?
Yeah, right. Thank you.
Yep. Yeah. So with that, I would love to pass the for the second group. You guys wanna share your screen and talk about project? It's up to 15 minutes for yours and remaining 15 for the other one.
Yeah, for sure. Thank you. Let me know if you can see my screen.
Yep.
Okay, perfect. So, hey everyone. Today we're excited to share our project talking about multimodal AI in action, Solari, an assistive device for accessibility. Our presentation will explore how we combined artificial intelligence, sensors, and smart design to build a hands-free solution that empowers visually impaired individuals to navigate the world more safely and independently. We'll walk you through the problem, our vision, the technology behind Solari, and the challenges we overcame to bring this idea to life. Let's get started.
Yeah, so just to introduce us all, so here's the team. My name is Kaniesa, and I'm a software engineering student, second year at the University of Waterloo. This past summer, I had the amazing chance to work at with TwelveLabs in Texas, and because of that, I've developed a huge passion in robotic-centric software.
Hey everyone, I'm Neha. I'm studying mechatronics engineering at the University of Waterloo. Over the summer, I was able to work on surgical robotics at the Hospital for Sick Children.
Hi everyone, I'm Daevik. I'm a biomedical engineering student at University of Waterloo. And this past summer, I was working at RICO, where I started to learn about agentic AI, which is kind of giving me more of an interest towards studying AI-based softwares.
And while Hannah could not join us today, she's very excited about our project and so happy that we can share it here today. She's also a software engineering student at the University of Waterloo, second year.
Let's talk about the problem. So while we were at the hackathon, my team and I were discussing big problems in the world, and we realized that there's a big disparity in the amount of support for visually impaired individuals. There are over 43 million people in the world who are blind, and they still rely on devices like canes and even Braille readers, but there's still a disparity there, and we wanted to bridge that gap by working on a device that uses AI to help the visually impaired and really give them that support and give them that confidence to navigate the world indoors and outdoors. Oh, Kaniesa, you're muted.
So sorry. So with Solari, we wanted to build something that was safe, reliable, hands-free, and easy to use. Next slide. And we wanted to negate the need for handheld technology like cell phones while still having a smart solution that was also mobile and easy to wear and carry around.
So, welcome to, now we're introducing our product, Solari, assistive technology for the visually impaired. Go to the next slide, please. So the Solari Sleek headset, as previously mentioned, is an AI-powered wearable for the visually impaired. Using ultrasonic distance sensors, buzzers, and a camera, Solari detects nearby obstacles and identifies key objects. It delivers real-time audio and vibration cues to help users navigate safely and confidently, both indoors and outdoors. Now here is a quick video demo showcasing the potential of our project. I don't think I can hear the video.
Oh, can't hear the audio?
Yeah, I cannot hear it.
Okay.
Course. Nearby, the young man is standing, looking at his smartphone. To your left is a closed door with a red exit sign above it. To your right, by a large window, is an empty red wire rack.
Solari uses TwelveLabs and Gemini to analyze videos taken on a Raspberry Pi camera and output the description of the scene around it in the Solari headphones. This can allow the visually impaired to picture their surroundings. Solari has distance sensors to detect any objects around and keep the user safe from any collisions.
Using Solari, a brand new physical accessibility device designed for those who are visually impaired. Thanks to Solari, you can now listen to the world surrounding you thanks to integrated cameras and ultrasonic sensors.
Let's start with video AI now. Unity could hear the new world, however you do it.
Solari uses the layer Introducing the Solari headset. So on this side, you have the Raspberry Pi connecting modules, which record the scene around you and send the data to the Solari API and Gemini API, which can process the data and tell you what's going on with the headphones. Meanwhile, on the other side, you have the ultrasonic distance sensors, which also have a buzzer. So the second you approach a sort of distance and people or objects that are coming their way, the buzzer will be right next to your ears, so you'll feel alerted. So the goal of the Solari headset is to help visually impaired users be able to walk and navigate the world without having to feel like they need a whole handheld device or have a cell phone on them or constantly. It's just right on them, they wear it, and they enjoy the day.
Sense with Solari.
And now to go a bit more in depth on how our system works and how we did it, let's talk about system architecture.
So on a grand scale, basically it's a simple headset that goes on top of your head, just like a pair of headphones. But we have two attachments to the headset. Basically, one has a camera on it and the other one has the ultrasonic sensor. So it's very easy, very simple, just something you prop up on your head.
On the camera side, quick 5-second snapshots of the environment are captured. These videos are processed through TwelveLabs to identify all obstacles or interfering objects, making it adaptable to custom user environments, since a user might experience different objects depending where they are.
Lastly, the ultrasonic sensors, which basically just use sound waves to tell you how far objects are used for more of an immediate safety feature. So if an object is too close to the user, a small buzzer will attach to the headset will buzz, allowing the user to tell that they are in immediate vicinity of an object and to move out of the way.
And like we saw in the video, just to walk you through a simple example, basically, we saw a boy walking in the hallway wearing a red shirt. So the camera records 5-second snapshots, and then we put it through the TwelveLabs API, which identifies the key objects. And then this is turned into a text description, a very long text description. But then we use Gemini API to make that text description into a simple, most important information that the person needs to know. And then we turn that into audio output. So that's what comes through the headphone speakers. Just some images showing the pipeline of the device and how it works.
Now, this project was not without its challenges. So some of the key problems we faced was what we call the QNX camera data pipeline issue. We struggled to get the Raspberry Pi camera feed properly formatted processing for QNX. Just the video data was not compatible between QNX and TwelveLabs, blocking real-time scene understanding. But we solved it by splitting the workload. So we had one Raspberry Pi running the standard Linux camera processing and AI scene analysis, which includes the TwelveLabs API. And while the QNX handles the ultrasonic sensors and the object detection system, this modular approach really allowed both systems to run smoothly in parallel. But the second issue we faced was an outdated Raspberry Pi OS and some compatibility issues regarding that. So our environment was running on an outdated OS version, leading to broken dependencies and compatibility issues. We had to just perform a bunch of full system updates and reinstalling packages, but overall, we were able to restore functionality while keeping resource usage minimal for wearable development.
You can learn more about Solari visiting our dev post or our GitHub, which contains just kind of like a high level of what we've already been talking about, but more in detail on how we've actually implemented it.
That's all for us. Thank you so much for having us.
Awesome. Yeah, thanks, guy. Thanks for the walkthrough, and I think it's a very interesting and impactful, application of technology. I think Hamza have a small comment on the chat. You want to address that?
Yeah, can you guys hear me?
Yeah, you want to ask the question?
Yeah. So I thought your project was cool. I haven't seen anything like that before. Just one idea. Maybe instead of it having it tell you the description of where you're going, what if like as a usability feature, it analyzes where you're going. It can like sense your head movements. And then if you're facing in a direction that has a potential obstacle, imagine if there was like some type of like vibration that happened, like in a video game. And then if you're facing a direction where it's a valid path, you won't hit anything. It like gives you like a little lighter vibration, like a green, it's good to go signal. Like just some kind of vibration sensing thing. That would be kind of cool. I don't know. Random.
Yeah, so currently we do have the feature where there is a buzzer attached to the headset and it'll buzz if there's something in your immediate vicinity. And we sort of attached it so that it's like facing. These are kind of like the way your glasses do. So if you turn your head, it'll only buzz in the way you're facing. But I do think the idea of it increasing or decreasing in vibration to how close you are to an object is actually a really great idea for implementation and something we would consider.
Yeah, like imagine blind people communicating with this device in some new buzzer language, like
Or like
based
Morse,
off,
maybe
yeah,
Morse
like
code
for example,
perhaps?
Morse, or like you create your own. Like it's just an interesting usability challenge.
Yeah, for sure, for sure.
Yeah, thank you for that suggestion. Just to keep in mind, we worked on this project actually in under 36 hours. We were competing at a hackathon called Hack the Six. So we were under time constraints, but we had so many ideas, and this is what we ended up with. And it wasn't without TwelveLabs help, we couldn't have done it. So thank you.
Fun. Cool.
All right. Yeah, thanks guys for walking over the details of the project. Yeah, so we got 50 minutes left. So the last group, you guys want to share the screen and start the presentation?
Yeah, I can share my screen right now. Okay. Can you guys see that?
Yep.
Perfect. Okay. So at Hack the Six, Karan, Aditya, and Barsa, we made Coach.ai. Coach.ai's motto is better access, greater athletes. So we'll talk about, sorry. Okay. We'll talk a bit about, in our agenda, we have introductions, we have the concepts and features of Coach.ai, a live demo as well, a bit behind the scenes of the tech stack that went into it, impact and next steps, the closing, and as well as a Q&A. So I'm Karan. I'm a first-year engineering science student at the University of Toronto. I'm interested in robotics, computing, and how technology can be used to solve real-world problems. I've been involved in robotics competitions, hackathons, and side projects that mix hardware and software, and I enjoy learning through collaboration and experimentation. Outside of classes, I like building communities around STEM, so I've organized hackathons in the past as well. And I like exploring new challenges that push me to think in creative and practical ways.
Hi everyone, I'm Aditya. I am also a first-year engineering science student at the University of Toronto. Hack 6 was actually my first experience with hackathon or coding, and so I'm super interested in ML, AI, and on finance. I've been working on the side in data analysis projects, and I generally love problem solving with math. And yeah, that's me.
Hi everyone, my name is Barsa. I'm an undergraduate student in software engineering at the University of Western. Some of my passions have always been in terms of game design and machine learning, and this was actually my first ever experience with a hackathon. This was the first project I've worked on at a hackathon, and it was a pretty fun experience. Okay, so our platform combines innovation
Just,
with
just one way.
accessibility.
I think
Oh,
you're still stuck on the screen.
oh,
Oh,
You're not moving. Yeah, go ahead.
okay, perfect. Our platform combines innovation with accessibility through four key features. The first is video analysis. Athletes can upload their training or game footage, and our website breaks it down to highlight strengths, weaknesses, and areas for improvement. This allows for any game or training footage to turn into meaningful, actionable feedback. Next, accessible coaching. We're not just focusing on elite athletes. We want to ensure that athletes in remote and underserved communities also get access to quality coaching. By bridging that gap, we're making performance improvement more inclusive. Third, multimodal AI. Using advanced models like TwelveLabs and Gemini, our system can process and combine different types of data to generate personalized insights. This means athletes don't just get generic advice, they receive tailored recommendations they can truly understand and apply. Finally, we built an engaging web app, a clean and motivating user interface that keeps athletes coming back, helping them stay consistent, track progress, and feel connected throughout their journey. Together, these concepts and features make up the foundation of Coach.ai, empowering athletes with technology-driven coaching that's both effective and accessible.
okay, so now I will get into a live demo. So I have it running on my computer right now. This is the upload portion of the website where users can essentially just upload a video of them playing sports. So for right now, I have a video of a tennis rally. Once that video is running, it'll 12Labs will be analyzing the video and processing that. So while that happens, Aditya can talk about why we created this project.
Sure. Yeah. So basically, I guess we created TwelveLabs. It was inspired from my background. So I'm originally from Newfoundland, which is a small province in Canada, and I've been playing competitive badminton for a decade now, and I'm 18. When I first moved to Newfoundland, I found it incredibly difficult to access coaching due to scheduling conflicts, court accessibility, and overall access to even information around badminton events. And so I mainly focused on playing tournaments, wherein I did well on other tournaments, but I remember distinctly last winter I got the opportunity to play in my province's their premier games, and so I won all my games but one, except the guy I lost to was from a remote indigenous community in northern Labrador called Rigolet. It's a town inaccessible by roads and requires air or snowmobiles. The kids from this town made up the indigenous team in the tournament, and they went on to win the entire tournament provincially. I soon became acquainted with the player I lost to and his coach, and found out that kids from Rigolet only receive in-person training for a couple months of the year, and despite that, they play exceptionally well. For all meanings of that word, they're outliers. It made me realize that there is a huge amount of untapped potential that's laying in smaller towns and communities in Canada and in the world in general, which is why to realize their potential into performance, we wanted to create a free, open, democratized software for supplemental sports coaching. And yeah, I think
so it seems like it's taking a little bit more time. So I can just talk a bit about the clean UI UX aspect of. So while we were making this project, we had shown one of the mentors at Hackathon, and they had recommended that we include something while the video is generating because it can take some time. So we, at the end of the hackathon, we added this. Oh, seems like it already finished generating. So maybe you guys saw it while Aditya was talking, but it's essentially like a small game that you can play. So now that the video analysis has been generated, it gives you strengths, weaknesses, opportunities, threats, recommended drills, and final insights. And you have the video on the right as well that was sent. So for example, here, this was a rally between Nadal and Federer. So it actually is swapped the names. But for example, one of the strengths is said that the serve that Nadal made was really good. It had power and placement. So I can click on this and it'll show the exact timestamp of the serve that Nadal made. Now we have weaknesses. So for example, it says, Nadal, your forehand returns sometimes lack consistency, which can lead to unforced errors and allow your opponent back into the point. So here, it's actually criticizing Federer's forehands because Nadal was actually out of place just before that clip, and he was able to get back. Now it has like opportunities. So for example, Nadal, refining your shot placement can significantly improve your ability to put pressure on Federer's baseline. It also has threats. And then after it does the SWOT analysis, it can give some recommended drills like backhand target practice or forehand consistency ladder. And these are sport specific drills that have worked for other athletes. And then lastly, it'll summarize all the insights into like a small 3 points.
Yeah, and just to sort of jump on here, you can also download all of the advice you receive in the form of a text file, and to sort of see what happens. We tried this sports analysis thing across multiple sports. So it's not just limited to racket sports or group sports. We also tried it with weightlifting and stuff, where its form is definitely it's a very minutiae, I think, to sort of track. And so yeah, that's just we tried to make it available to a variety of athletes.
So I'll get back to the presentation. Okay. So I'll talk a bit about behind the scenes. So for the backend of our project, we're using Fast API, Python. So this handles all the backend logic and connects all the queries of the TwelveLabs API and the Gemini API to then send it back to the front end. So it allows us to use the AI services quickly and efficiently. Our front end is Next.js with TypeScript. This allows us to basically, because we're in a hackathon setting, it allows us to build a responsive, scalable front end really fast. And it's usually has a lot of online support. So that's why we went with that option. And then the AI components, as I mentioned, are Gemini API and TwelveLabs API. So we use both the Marengo and Pegasus model from TwelveLabs API to analyze the video, and then using that analysis, we send it to Gemini API purely for processing and output of what TwelveLabs created. So the next.
Looking ahead, we've identified 3 key areas for impact and growth. First, community growth. Our goal is to evolve into a truly community-centered platform where users not only benefit from AI, but also support each other's development. This means that in the future, we would want to implement a community tab where people can find other people that are playing the same sport and want training in their area, and it would allow you to train with someone live. Additionally, we want to add mobile accessibility. We're working on building a more mobile-friendly version, making it easier to users to access our platform anytime, anywhere. This would probably come in form of an app. Due to us doing this for a hackathon, we only did a website. However, in the future, we would want to make it a mobile app if possible.
Right. And to sort of jump on that, I mean, this entire project was built and shipped within, I think, less than 36 hours. And so there's definitely a lot of room for future improvements. One of them being expert enhanced insights. And so I can say from my own personal experience that sports is not a lot like academia, where there's often best practices or an objective right or wrong. Sometimes there's nuance required behind form, technique, and overall strategy as well. And so to sort of implement that, we're working on what we'd like to work on, incorporating advice from certified coaches, sort of crowdfunding and labeling data, and to sort of ensure that the advice we give is first off accurate, and B, it's to ensure that it's accessible to a wider range of resources, because the advice that a professional would need is vastly different than the advice a beginner would. And so that's something that we for sure want to work for in the future, and hopefully make it an even more in-depth and more impactful analysis. Thank you so much for having us. That was our project, Coach.ai. I think it was a great experience building that, and it kind of showed that like as a group we wanted to target a place, especially as first-time hackathon, hackathon attendees, where you wanted to target the intersection between technology and community. And I feel that 12Labs has enabled us to do that. So yeah, we're very grateful for that.
All right, thank you.
If you guys have any questions, feel free to, and if you want to check out our dev post or GitHub, we're always, you can always scan the QR code as well.
Great. Yeah, I think we have like maybe 3 minutes left for the remaining. So if any question for this group and or the other group, feel free to unmute and you can ask on the Zoom chat. Spot analysis is I think it's a pretty popular use cases for TwelveLabs. We actually have a lot of like customer in this domain. So yeah, I think like in terms of coaching feedback and providing quality analysis for players, I think that's something we actually been thinking about and developing in-house as well. So it's great to like see that you guys can already think about like these use cases and try it out, right, for specific footage. Yeah.
Thank you.
Yeah. Okay. Yeah, so if there's no more question left, then I think we can close up the webinar. Thanks everyone for joining today. I hope all your question. Okay. You want to ask, Hamza?
Yeah. I just got a question about a use case for 12Labs. So right now I'm working at Daimler, which is like a trucking company, and I'm building some of the future active safety features, like in terms of like automated cruise control, all that for our trucks. And I was wondering like to what extent can I stretch the capabilities of 12Labs? For example, one feature we're thinking of is we're filming vehicle data. Like we have hundreds of hours of vehicle data being filmed, and some of those vehicle data, like there's collisions that happen, there's near misses. So I'm wondering, like, have you heard of any of the customers of 12Labs using the API specifically for like these scenarios where, for example, you're trying to see all the vehicles in a video, categorize this as a near miss, a collision, or perhaps trying to find out exactly where signs are on the road during the video, and then calculating the times between when a sign appears and when a sign disappears, and then like calculating vehicle speed. I'm just curious, have you seen anyone doing that yet?
Right. So public safety in general, I think we do have like quite a good amount of customer use cases in that domain. Everything ranging from camera monitoring to we have someone asking to use TwelveLabs for like detecting licensed vehicle and then figure out how that happening. So I think like what you describe here is the ability to like detect or like very fine-grained moment on a video clips.
Exactly, yeah.
Raise alert when like a certain action happening, and then provide additional analysis right on top of that specific segment. So when you think about like the combination of our model, and a lot of these projects I think also demonstrate this today, right? So we got the embedding model called Marengo that is used well for search, right? So we can, if you set a predefined list of queries that you want to search for, like vehicle collision, explosion, or like high speed, right? Those are the queries that you use. Then you can like trigger the search every time when those action happening, right? And then return that on the front end. And then after that, once you identify those moments, and then you can like use the Pegasus model, which is the other model that we have to perform in-depth video analysis, right? Just like how, let's say, the Coach.ai team did that for the spot component, right? You just provide, you could come up with your own prompt, and then that is contextually relevant for your footage, right? And then you prompt it to return the right analysis, right? I think spatial and timestamp understanding is something that our Pegasus model is I think we try to improve, and we like doing a decently good job,
Yeah.
right? So with some unique and high and intelligent prompt, you can definitely get it working.
Yeah, I
And
was just curious about the feature of being able to like, could it be able to like detect how fast a vehicle's moving based on a video? Like, is it smart like that? Can it analyze the frames, analyze the context of the video, and give a good estimate of a speed of a vehicle?
so I think that's an experiment you have to run for yourself to see the quality. In general, I think like, you know, if you working with any like foundation models, the more context that you provide to the model, the better it will be able to like have good performance and hallucinate less, right? So in this scenario, like there are certain, you know, in order to estimate like the speed, right? Then maybe you can capture like, for example, the first group, they talk about VideoRAG, right? So you can bring additional data from somewhere else and serve that as the other source of context that can help enhance the input quality when you before like fitting that into, you know, our model. So like it's basically they're doing some pre-processing, right, of your video content, so that when you give that to the model know exactly what to look at, right? So if, for example, like if like, you know, on that frame, right, the truck is moving, if you know, the truck is like, you know, like 10 seconds, right, moving from like this one bridge to like, you know, middle of the bridge, right? Have like,
Yeah.
from qualitatively looking at, then, you know, this is a possible estimate of like it's a potential guess of like, you know, the speed of the truck, right? So given that, like so like raw truth information, it can like guess how much of a yeah, like the speed of the vehicle, right? When being prompted to ask so, right? So yeah, that's my proposal, which is they do as many pre-processing and context engineering as possible for your input, so that like it reduces less burden for the model to like have to guess for the things that it like visually cannot see or cannot hear, right, on the video.
Okay. So yeah, basically I just have to do, the model's not smart enough yet to do it, basically. We just have to work around it. Get it?
Yep.
Okay, thank you.
Awesome. Yeah, thanks for the question. Yeah, thanks everyone for joining. And again, the speaker for presenting, and the session recording will be available on YouTube earlier next week, and I'll be sure to share with you. Yeah. Thanks for joining, and hope you enjoy the rest of your weekend. Bye.